Hey guys, welcome to our YouTube channel Mainframe Girls. In the last video, I have explained you what is dataset and mentioned the types of datasets. So today we'll discuss what is non-VSAM dataset types, part 1. The first type was non-VSAM types. So in this, the datasets can be divided into two parts, that is sequential, which is physical sequential, and partitioned, which is partition organized. In partition, we have two types, that is partition dataset and partition dataset extended. The first and a basic file is physical sequential dataset. It's a basic flat file in mainframe. It's like a normal file, which means like how do you write in a file? When you write it one after other, like one line after other, one line after other. Even if you scratch some line above, you cannot rewrite on that line, right? So it's one after other. So it's a simple file with records stored in the order that they are written. Means it's like, if you see here, so if this is the first record, so the second record, if it is written, it will go here. Third record, it is written here. Fourth is, if even this record is deleted, the means the next created will not be next entered record will not go here. So the next entered record will come here, fifth one, sixth one, seventh one. Even it is deleted, that place will be empty like that. It will be empty, and but it won't be used by the new coming records. So the new records are appended at the end of the data set. It means whatever you are writing, whatever the new data is going into the data set, it will go at the end of the data set. So maximum this file can be in one volume. It's a basic data set, will be there in a one volume, and it can go up to 16 extents. I'll explain you what is extents in upcoming video, but it can go up to 16 extents in one volume. And this file has an attribute of extending up to 59 volumes. Means if you're creating a file with a more space, then it will go to 59 volumes. It can take up to 59 volumes of space, in which it can take up to 944 extents. Remember this word extents and volume. I'll tell you how this will be spanned and how it will be expanded in those volumes. And here we have another type called an extended. When there is a word called extended, normal data set will take only 16 extents. Like I have mentioned here, it will be taking only 16 extents in one volume. But when it comes to an extended data set, it can go up to 123 extents. Remember the word extents, I'll explain you in the next video. So it will go up to maximum of 123 extents on each volume. But the physical sequential, it will go up to only one volume. So physical sequential extended can span up to 59 volumes with 123 extents, which is 7257 extents. Okay. So physical data set can go beyond. See, normally when you create a data set of normal physical data set, it takes 65,535 tracks. Okay, but when it is an extended data set, it can go beyond 65,535. Next file is partitioned file, partition data set. Okay, so this is so it is like a library. So if we see the library, how the library will be, think this is a library. So in that, how the books will be ordered. Think you have each row, this is of history, economics, politics. So like there is a different books, and in that books you will be having some data. So here in PDS files, so the PDS files will be having members inside them. So names are different names inside them. So with that name, inside that names, you have this PS files. Like the data is like PS files. Like I have told you before, the data will be stored or appended in the end of the record. Like one after other, the data will be entered. So in PDS file, you will be having PS files, but they will be like members. It will be like a big library, which will be having a single name. With that name, you can access to different members. You can create, okay, you can, so see, a directory of a sequentially organized members, each of which contains sequentially organized data. So you can create the members inside them, inside each inside each data set. Then after that you can access that members, and it's like a set of members you can put in one data set, like one file. It's like how a set of history books are kept in one rack. It's like that. So it contains members in the data sets. Like I told you, each data set will be having a members, and each individual member can be accessed without searching the entire data set. Yes. So how can you search is, once you go into one PDS member and you just give find F space the member you need. Okay, there's no need of searching one by one. You just give F space the member you need, or L space. It's like F space the member you need, or L space the member you need. So it will automatically locate the file where the file is. So members are like how many members you can create in one PDS file. If that is a question, how many you can create by a formula which is called 6n minus 1. The 6n here n is like if you need 50 members, 6n minus 1. Like suppose if 6 5s 30, 30 minus 1. So if you give n equals to 5, if n is equals to 5, you will be creating 6 5s 30 minus 1. It's like 29 members. So if you are giving, while creating a PDS file, it will be asking you how many directory blocks you need. So in this directory blocks number is n. So if you, while creating a data set, if you give directory blocks as 6, then that in that PDS or in that library you can put 6 6 or 36 minus 1 means 35 members you can create in that PDS. So this data set will be there in only one volume. It cannot extend more than one volume. Like I told you in PS can be shared up to 59 volumes, but when it comes to PDS, it can stay in only one volume, and in one volume it can go up to only 16 extents. So the partition dataset, the PDS dataset, what I'm saying, it has some advantages and disadvantages. Okay, so the advantages are, you can find the history book in the history rack and the physics book in the physics rack. It means you just need to know the rack name, where it is. So you can easily group a set of data sets under a single name. Okay, so it's like how I told you before, there will be one file created, that under that you will be having a members according to the n or the directory block which you specified, and you will be having the members in it. Okay, so this members can be, the next advantage is, can be lesser than a track. And so when you are creating a PS file, which I told you before, PS file, you give a particular space. Okay, I'll explain you what is a track, how many bytes it is, how much space it is in an upcoming video. But when I'm saying you give some particular tracks to create a PS file, but when it comes to a PDS file, you can simply create a small data sets like PS files inside PDS file, in which you can simply write just hi, nothing more than that, and just here you can write just bye, like that, because you'll be this big data set is already given a space, and in that space you are voluntarily creating this data sets, this small members. So this, you don't need to specify any name. You can make these files bigger and you can make them smaller. But when it comes to a PS file, what happens? A PS file, while creating, you give that, okay, this file can be 1 GB. So when you say this file can be 1 GB, it will be only 1 GB. But when it comes to members, if you have given this PDS member as 20 GB, if you have given this PDS member a 20 GB of space, so this members here, it can be 1 GB, it can be 2 GB, it can be 10 MB, it can be 3 MB. You can create up to 1 byte also. It can be 1 byte. So like that, it's an advantage. Smaller than a track can be allocated. So the next advantage is multiple PDS can be concatenated. The word here concatenated means, suppose if you have two PDS files. Okay, two PDS files, this have some 20 members and this PDS file is having some 5 members. and you want this two racks to be mixed, you want this two files to be mixed. Okay, this you have this ability that you can mix this two files, you can mix this 5 files into this 5 members into this 20 members. So you can concatenate two PDS files. If these two are concatenated, it will take this. If you want this name to be the first name, you give this name in the top and you say that, or you can concatenate up to 5 to 6 files. How many PDS files? Depending on this file's directory blocks. Suppose this file is having a directory blocks of 10, which means 6 times 10, 60 minus 1 means it can hold up to 59 members. Suppose if you want to enter 5 some other member with some 20 and other member with some 4, and you want all this to be mixed up to this member, you can simply do a concatenation. There is a job, there is a program which you can run, and after running that program, all these members can go into this. If suppose if you are moving more members than 59, it won't accept, but if you are moving up to 59, the concatenation will work and you can pile up all the members in one PDS data set. Okay, the next advantage is you can easily create this file using our ISPF panel. I'll tell you what is an ISPF panel, which is a mainframe panel, a basic mainframe panel, or with a JCL, which means the program code which we use in mainframe, which is called JCL. You can easily create it. Okay, now we'll discuss what are the disadvantages. So the disadvantages are wasted space. How? So if you're creating a PDS and you're giving n, that is our directory block, equals to 20, so you're requesting a space of 6 times 20 minus 1, 6 to 120 minus 1, that is 119. So you are requesting 119 of directory blocks of space, and you also allocate with some GB of space. Then what happens? So all these directory blocks and all this space what you have allocated will be wasted if you are not using that space. If you have asked for some 20 GB of space, and this all space will be wasted. It will be just waiting there, or that space is like created and it's like waiting there for data to come, and that cannot be used by any other data set or any other file. So the next one is limited directory size. So as I told you, if you have given 9, as I told you here, if it is 59, you cannot go beyond 59. You cannot create a 60th member in it. You can create only 59 members in it. You cannot create 60, 61, 62. It's like if you have given directory blocks as 2, you can create only 6 to 12 minus 1. That is 11 files. That's it. 11 members in it. So lengthy directory search. As I told you before, if you want to search something in the member, you have to give F space the member name, L space the member name. But how the members are aligned or how the members are arranged in a PDS is they are arranged in an alphabetical order. So one after other, they are in an alphabetical order. So when you are searching, when you have given L space the particular member name, how it will search as an interpreter? It searches after 1, 1, 1. Suppose if that is having n equals to 20 and a bigger directory block with 119 members, it has more members, then it will, if you are given something which starts with Z, just example, just think it will search on each member, and it will take up at least 5 seconds or 6 seconds to give you that member name. So it takes a lengthy directory search. The last non-VSAM dataset is partition dataset extended. So as I've told you before, we have some disadvantages with PDS file. Think this is a PDS file, okay, and these are the entries in PDS file. So members, like these are the members which are getting created, and think that this member is deleted, and this member is deleted, and this member is deleted. But when a new entry comes, it doesn't go to this place. It will be added at the end of the, like as I told you, it will be appended at the end of the dataset. So new members will be appended here, like it's a sequential entries. So as it is a sequential entries, it will be coming here. And as I already told you, it has a n equals to directory block parameter is there. So what happens if n is equals to 2 or 3 and only that many members, as I told you 6 and minus 1, only that many members you can create in that particular PDS member. But coming to this extended format, we do not have that issue. It can PDS which does not have a fixed size directory, is an unlimited, it has a limit but it's not a small number, it's a big number, and can reuse deleted space. So if this space is deleted, this space is deleted, it will go here. The new files will be coming into this place. Even in PDS, we have a program to get this deleted or free space by using, we have to do reorg, that is reorganization of the data, or compression. There are two codings which we can do and with which we can reuse this space, but not automatically. It will not be done automatically. But in PDSC, we can the new members will be added in the deleted members place. And the next one is, they also have a better facilities of data sharing. So what happens is, if this is a PDS file, and if me being a user 1 and someone is a user 2, if two users are using this data, I can create a member here and the other user can also create a member here. Means this file can be used by as many people as possible. Means the data sharing is possible. But when it comes to PDS, there will be a contention. It will say that someone is holding this file. So it will be saying that when you open, or if you want to do some process in those file, it will not allow you to do that. And PDSC stores programs as a program object. Okay, so what is program object here is, the PDSC stores the data, whatever data you have in it, as an object form. Okay, but coming to PDS files, it will store as a load modules. Okay, as one by one load modules it will be storing, and the PDSC stores in a program object type. And as I told you, it's an extended, and but as it's an extended, it can go up to 123 extents in single volume, and a PDSC can be there only in one volume. It's unlike like PS, it won't be there in 59 volumes, but it can extend up to only one volume, but 123 extents. It can go up to 123 extents. And as I told you, the single file, normally a file will be in one volume. If it is getting created, it will be only 65,535 tracks, but PDSC can go more than 65,535 tracks and 123 extents in a single volume. And as I told you, an unlimited fixed, it's not a fixed size directory. A single PDSC can have these many members. It's 5,22,236 members. Mostly we don't create that many of members, but so that is why it is portrayed as an unlimited members of, compared to PDS, we can create an unlimited members in PDSC. So in the next video, I'll explain you the attributes of this data sets and how to create this data sets like PDSC or PS. What are the things we give while creating or while allocating this PDS, PS and PDSC files. Thank you for watching our video. Please like, share and subscribe.